everyone. Welcome to the Popcorn Innovation Series, a special pre-summit conversation created by Cat Squared and co-branded by Mavens and Manufacturing. I'm Megan Zimba, host of Mavens and Manufacturing, and I'm excited to help bring a new layer of storytelling to this year's Popcorn, the Innovation Summit presented by Cat Squared, happening August 10th through 13th at Oaklawn Racing Casino Resort in Hot Springs, Arkansas. For nearly 30 years, Cat Squared has worked with food manufacturers to bring greater clarity, control, and visibility to complex plant floor operations. This year's summit builds on that very foundation by looking at where the industry is headed next. We're setting the stage for the conversations that matter most across food manufacturing right now, including connected operations, predictive intelligence, traceability, AI, interoperability, cybersecurity, and the shift from operational complexity to operational clarity. Because the future of manufacturing is not going to be built by more disconnected dashboards, more isolated systems, or more data nobody knows how to use. It will be built by people, partners, and technologies that connect the dots from farm to fork. Today's conversation is part of that larger story. In this episode of the Innovation Series, I'm going to talk about the Industry 4.0 without the buzzword fog. My featured guest is Dr. Amit Morey, and his popcorn session will explore how poultry processors can connect existing automation, sensors, and plant data into cloud-based analytics that improve efficiency, food safety, and yields. Before we get started, I want to say a special thank you to all our sponsors supporting the Innovation Series, including Core Time, Cabin Plant, CTB Group, and Teguar. For more information on the event, scan the QR code in the corner. In this episode of the Innovation Series, I'm going to talk about Industry 4.0 without the buzzword fog. My featured guest is Dr. Amit Morey, and his popcorn session will explore how poultry processors can connect existing automation, sensors, and plant data into cloud-based analytics that improve efficiency, food safety, and yields. Amit, it's so great to have you here for the Innovation Series for the Popcorn Summit. So can you just give us a little bit more background information about yourself and how you got involved in the food manufacturing industry?
I am an associate professor in the Department of Poultry Science at Auburn University, and I work on technologies to improve food safety, quality, and shelf life. One major thing that I have always yearned is how can my science benefit our stakeholders? The goal of my lab is science for the benefit of mankind, and hence our stakeholders are the ones whom I want to really impact and create a positive impact on them. My undergrad is in fish and fishery sciences, where we're very closely ingrained with the stakeholders, with the people, with the fishermen, with the processors, with equipment manufacturers, and everybody else. During my first master's degree, I developed a process to reduce the usage of water while ensuring the quality, the biochemistry of the meat that was produced. And during my second master's, I did seafood waste valorization and seafood spoilage microbiology and so on. So moving on, came to Auburn for a PhD in poultry science and worked on food safety, microbiology, as well as improving shelf life and improving processes while creating clean label products. That's how my career moved, and I really like applied research. Hence, when I got into assistant professor job, I decided to solve real world industry problems that our stakeholders face and that we can provide meaningful contribution to our poultry sector. So that's how I got into the technology space and what I'm doing in terms of helping our stakeholders.
I think that's so cool because if you're someone like myself, you don't really connect the dots in that way where technology is so connected with food manufacturing and, helping out with this summit. I'm seeing more and more of those connections being made. So it's really fun to see the whole value chain of poultry manufacturing and processing. One of the things that I wanted to start this conversation with is the term Industry 4.0 is one of those buzzwords that's going around in manufacturing. And it can be kind of confusing to anyone that's outside of this industry. So what does Industry 4.0 mean in poultry processing when we remove all of the buzzwords surrounding it?
Yeah. Poultry 4.0 means improving efficiency, improving processes, understanding, better understand quality, better improve food safety, and be able to predict and prevent incidences that could happen that could affect a poultry processor at any given time. All this is based on traditional data as well as incoming continuous data, which our poultry industry is collecting significant. What poultry industry 4.0 means to our US stakeholders is that we now would be one step ahead of the curve and would be global leaders in the poultry industry.
So you mentioned the data that people are collecting. Can you provide a little bit more detail on what kinds of data our processors are already collecting, but not really fully using? Because, all these advanced technologies are kind of overwhelming everybody with the amounts of data that they're collecting. So what types of data are we already collecting, but not fully using to our advantage?
Yeah, I think poultry industry is one of the best sectors to initiate Industry 4.0 because we are so vertically integrated. Even in a processing plant, it is a continuum from receiving of the chickens all the way to the final product that is going out of the door. So if you look at data, say for example, quality assurance data, they are collecting time temperatures in the chiller. They're collecting the PA concentrations in the chiller. They're collecting the Scalder temperatures. They're collecting weights. They're collecting, dead unravels. They're collecting data at post evisceration when they're observing birds for condemnations, carcass condemnations, and so on. So there is so much data that is being collected on paper. So the format of the data is either paper, handwritten data. There could be data that is directly coming in from sensors, like say the PA sensor or the time temperature, the temperature sensor that is in the chiller. There could be line speed data, or there could be a temperature data in the Scalder. There could be belt speed data. So there are so many data streams that are being collected, and they are being sent to dashboards, but those dashboards are individual. And at times, when you have handwritten data, it takes time for an individual to give the data to somebody, for them to write the data, for them to transcribe the data into an Excel or some sort of a digital format. And it takes quite a bit of time for this transformation to happen. And with the industry going so fast, the processing speed being so fast, somewhere about 140 to 175 words a minute, you really should not have that much of a lag in understanding what the data is telling us. If you're waiting for a couple of days for us to understand or even have time to figure out what is going on, we have lost significant amount of time to make a change, a positive change that could be impactful for our processors in terms of yield, in terms of efficiency, in terms of gaining, in terms of profitability and reducing loss.
Is there a reason why useful plant floor data is staying trapped in those types of silos that you mentioned? Because you were saying that they're running through the dashboards, but they're individualized. Is there a reason behind that? Why is this staying siloed?
Yeah, so I think the way we are set up is
Okay.
one of the ways that the data remains siloed. Also, we have different departments and operations versus QA versus the engineering department. They're collecting their own data, large volumes of data getting collected, but the data doesn't talk to each other. And because of that, it becomes very difficult to get a global perspective of what's happening. Granted, there are companies who have dashboards. They have individual dashboards, but they're not merged. And the way we are set up, that needs to change just a little bit. We are there, but we can take one extra step in terms of merging those data sets, in terms of overlaying it with machine learning algorithms, in terms of artificial intelligence, to separate out the signal from the noise. because otherwise you will have so many dashboards and so much data that is coming in. It becomes fairly impossible for somebody to sit in front of the screen and constantly monitor the data. So such kind of systems, if we were to make that one little step, I think we would be in much better shape compared to where we are now.
Okay. Where can better analysis of plant food data more directly improve operational decisions?
I think everywhere. A couple of things I think are critical, say, for example, food safety.
Okay.
USDA, FSIS is having stringent regulations, and our industry is doing absolutely phenomenal in complying with those regulations. USDA, FSIS is on top of it as well. So our product is absolutely safe, but we can do something better. For example, if we have, incoming size of the size of the birds that are coming in, we understand the feed withdrawal, we understand the time temperature, the climatic type temperatures when the feed withdrawal starts, we understand the flock history, we will be able to predict, and we'll have some traditional data as well to understand what kind of salmonella loads are we expecting into the plant. We can adjust the concentrations of chemicals that are in there. We are working on camera systems to detect fecal contamination, and so we remove human interference in detecting fecal contamination on carcasses, which USDA FSIS has a zero tolerance for. Now the cameras can do a much better job of collecting all that information. Our algorithms can, with a fair degree of precision, accuracy, we can detect where the fecal contamination would have come from the GI tract. So based on that, we can say where maybe there's a machine that needs to be fixed or something needs to be done. And so once all these things happen, we may be able to improve food safety of whole chicken carcasses, which we already have achieved the targets, but then further on going into chicken parts as well. There are x-rays and machine vision systems which detect bones in the product. Now, if you're continuously collecting the data all the way from the flock and the feed and the nutrition of the bird, tracking it all the way down, you will be able to see which birds and why there's, say, a keel bone or a fan bone, what's going on there, and able to connect the dots and take action even before things could happen, if you will, and maybe train the folks on the line or something like that. So you can improve the efficiency of the operation that.
That's so interesting that it's getting so technical and being able to see the different things or deviations in the actual flock too, and then just come up with a better product. Do you have a specific example of a plant fuller decision that improves when teams can see patterns earlier? Like, do you have a specific example that you can relate to? I know with certain information you can't share specifics, but is there one that you can share without complicating any NDAs or anything?
Yeah, no problem. No problem. We are researchers and we are here for our stakeholders. Say, for example, we are looking at a camera system where we can detect the bruising on the wings. And wings are very expensive. Bruising on the wings is a problem. And you reduce the yield, you increase your losses. So how do you use imaging systems, which are not just simple camera, but a hyperspectral spectroscopy systems, imaging systems rather, which with 5-layer machine learning models to understand how much loss is going to be in that particular wing, where the bruising is, what is the color of bruising, and potentially connect that with the flock, catch, crew, transportation, and all the other data that is coming in. So at the flock level, you will be able to understand why maybe there is bruising at a particular joint, why there are certain broken bones. And once you have all these deviations captured, because these become signal, not noise, because noise is, for most part, you're going to see the same thing over and over, but these are the signals that you can capture and analyze a lot more deeper. And once you analyze them a lot more deeper, you do the interconnectedness of the data. So breaking the data silos all the way from the farm, now you have an opportunity to make a decision. Do we need a better catch crew? Do we need to train them better? Do we need to adjust our equipment properly? Do we need to do something else in the processing? Hence, now you will be able to reduce some of the losses that potentially a processor could have. Or another example could be a chiller, a chiller concentration, which directly relates to, it's a CCP critical control point. So it relates to food safety. I was doing a project several years back where we were looking at why there is a salmonella occurrence, but the chiller PA concentrations on an average were the same. And I asked for, in-depth data of the chiller, hourly data that is getting collected. And as I started plotting it and I saw where that one sample was collected, you could see that the PA concentrations dipped, and that is where this data was collected, the sample was collected. That sample came out as positive. And then as it went up, it started to, the salmonella problem was gone. And you could see the patterns in the data as well. So some of these deviations become significantly important, which otherwise get lost in the average data that gets collected. So these are some things that could benefit the processors, and there are a lot more such examples.
Well, it sounds like too with a better collection and understanding of the data, you're really helping teams move from a reactive state of problem solving to a more proactive problem solving to do earlier intervention when necessary. Do you have something specific to that perspective where the salmonella was a perfect example of maybe preventing early intervention? Is there another example that you can provide where patterns that they were seeing really made them proactive to stop something from leaving a certain point of the supply chain and actually going into the consumer portion of it?
Yeah. So when it comes to the plant floor decisions and team, say, for example, it could be related to temperature and energy consumption. We talked about food safety, we talked about quality, meat quality and detection, but let's talk about energy consumption and operational efficiency. If they were to collect the data on, say, chiller water temperatures, the water usage, you will be able to understand how much energy consumption there is compare and say the amount of belt running that happens, the shaking and the vibration that happens. All those data can be put together to better understand the efficiency of energy efficiency of the plant, thus reducing the input costs and improving the profitability of an operation. It could be that we worked on a burger project some time back, where if we have data coming in, say it could be all the way from the boxes when they are prepared, when the robots put them together, and how much glue it goes on and how much is that box, and how can that be used as stair weight in the final boxes, how much meat is getting deposited out of the depositor, what is the weight of the loss in the weight, and so on. So there are so many parameters that we can collect the data on. And depending on the supplier, we also found that if the supplier is far away, the loss was higher, slightly higher than the others, which were sending slightly fresher meat, if you will. And 1 or 2 days itself could make a big difference in the losses. So all this collective, even the data silos merge, the distances between the supplier to the manufacturer, the time required for the manufacturer to use that raw material into a product, the lines and the line speeds and all those things. Now, suddenly, once you merge the data, you'll be able to start adjusting the lines ahead of time. And that kind of gets into something called digital twins.
Okay.
So digital twins are where you create a simulated environment based on the data coming in and historical data. And in the digital twin, you can change certain things to understand what would be the effect on the real process. So then you can go back to the real process and you can start optimizing things. And as you optimize things, the data from the IoT is going to get back into your simulation. And it will change and it will tell you what is the real world, what is happening on the lines as well. So those kind of mergers and then digital twinning, which we are getting into actually in a very interesting manner, you will be able to make better, understand patterns earlier, make decisions in the simulation, understand what could be the output, and go out in the plant, change those settings. You will be able to see what's going on.
So, drawing from your applied research, what separates a practical Industry 4.0 application from an idea that sounds good but does not hold up operationally?
Yeah. And I've written quite a bit on Industry 4.0. I can
Okay.
tell you that the poultry industry is pretty close to achieving Industry 4.0. Yeah, we are very close. The reason is we have equipment, we have technology that is being heavily used, that is collecting data, that is sending data at different rates, different velocities, veracities, and we are trying to capture all that information in different dashboards. That's the problem, is that the data
Mhm.
is not integrated. So when I and IPPE spoke to a company, they have a tumbler. It is a classic, amazing tumbler, which has
Mhm.
all the bells and whistles that you can think of. A nice computer, it can show things, what's happening, it can send an alarm, but it does not, it is an individual piece of equipment that gives
Mhm.
individual information, but it's not tied to the information coming in from the previous step. It
Mhm.
is not tied to anything else. So once we start to connect the data, which we are already having, combined
Mhm.
with the machine learning algorithms and overlaying that data layer, I think we will be in business very quickly. And with moving forward, we are developing something called federated machine learning models, which will
Okay.
even help our processors to ensure that their data doesn't leave the processing plant, whilst
Okay.
helping the other processing plants in their entire, say, vertical integrated operations
Mhm.
to benefit from the learnings of that particular plant. So there
Okay.
are so many interesting things that are happening. But the good part is we already have the data sources. We just need to take the next step. It's not utopic at all. We are already
Mhm.
there. We are already having dashboards. There are several companies in the space, Cat Squared included, have the data
Mhm.
streams. We need to add meaning to the data. We need to separate the noise from the signal. We need to understand what the patterns in the signals and connect those patterns to something in the previous steps in that entire continuum to make better
Mhm.
decisions. So ultimately, we're going to have data driven decision support systems that will help our processors significantly in the future.
I think that's an interesting point because I know there is a lot of frustration with some of the team members who are actually working with these different types of technologies. There's a question of, okay, why does this matter? Why do I need to care about this? So, how do you approach teams in a way where they know that the analytics they're collecting is useful instead of just another screen to check? How do you make that process a little easier for team members so that you have buy-in from them? Because I know that there comes a point where they're going to feel overwhelmed, right? So maybe this is a two-part question for you. What makes analytics useful for plant teams instead of making them feel like it's just another screen to check? And then when does more data become a burden for those team members?
Yeah, I think our personnel and processing personnel, employees up and down the chain are extremely busy with the day-to-day tasks that they have been given. On top of that, we have shortage of people in our industry. We're trying our best to make things happen. And we are on top of things. I mean, there is no doubts about it that people will work extra, but they will make sure that they've got the best product out for the customers and that they protect the brand. And that is where it becomes burdensome, is because the legacy systems that we have are working to suffice what we want to do on a day-to-day basis.
Okay.
So if we want to take the next step in profitability, improving efficiency, improving safety, we need to push in that direction. The decision to go into that direction comes from the management and upper level management who can change the culture and train the people under and at processing plants, at the QA technicians and technologists and so on and so forth, to understand data better, because they're seeing it every day. But they don't have the time to sit down and check and stare through the dashboard and the data. If you're collecting data every minute, they don't have the time to do that. And hence the machine learning models, which does prediction, description, prescription, and prediction, three things, would actually reduce the overwhelming data, and that somebody has to look at to make a particular decision. So data has to be used along with certain analytics tools, not just dashboards. Dashboards do show data. Dashboards do show high and low and up and down, but you have 35 dashboards and 35 graphs, and you can't connect today's data with last week's data with the week before's data to understand what could be happening, what could be going wrong. And so adding that extra layer could help. Training those existing people would help. The third most important thing is that we need to have trainings where we can provide scientific understanding of poultry processes to our plant personnel, and at the same time help them to understand the data that they're collecting and merge the scientific poultry discipline with the data discipline, so that they can now make a collective stronger decision and make a change in the lives in the lines and create an impact on the industry.
One of the conversation that I had recently with a gentleman who's part of the print publication industry. So he's a journalist for technology and engineering and manufacturing. And he used to work for a food publication. And he mentioned how food manufacturing is kind of behind some of the other industries in early adoption or adopting Industry 4.0. But it sounds like you have a different opinion. Maybe we're not as far behind as he kind of led me to believe. But are there specific barriers that you've seen? I know you mentioned leadership. So leadership is probably a big component in companies adopting some of these technologies, and then the necessary training. Are there any other barriers that exist or that you've seen where companies are hesitant to adopt 4.0 into poultry processing?
The legacy systems, definitely, because the legacy systems have been working. If it ain't broke, don't fix it.
Right.
If it's working, don't worry about it. Because if I were to try to make a change today and something happens, now the company who was providing the technology is gone. You fired them probably, but your processing is affected, your bottom line is affected. So having the confidence to make the change without having a major impact on their operations, negative impact on the operations is very important, which will help us to replace the legacy systems that we have.
Because that's probably creating a different silo in its own. Because with those legacy systems, you're probably not accurately collecting that data from those systems, correct?
Yeah, correct.
Okay.
Absolutely. I mean, in several instances, we are still collecting data on pen and paper.
Yeah.
So if you're collecting data on pen and paper, then going and transcribing it in Excel, and then somebody makes a graph after a week or two to see how is the operations going on. I mean, you've lost time, and the impact is almost negligible to zero. I mean, you've learned. So I think
Right.
having some modern systems is beneficial. But the other thing that happens is, again, like I said, it is their bread and butter. if I go in and change something and something goes wrong, it is them who get affected. So I think there is a need for a better, stronger trust. The fact that we can
Okay.
do some pilot testing and do small, sequential, linear changes in our systems such that they can be improved over a period of time is critical as well. But also there is a concern about cybersecurity, and there's also concern about data sharing. So who owns the data? Where does the data go? Why should I share my data? Those questions are very pertinent and very important. The other
Mhm.
important question also is cybersecurity. What if somebody hacks into my system? We're talking about Industry 4.0, where cloud computing is a major part of it. But maybe there are ways to circumnavigate that, which we are trying to do in a recent project in the poultry sector as well. So
Okay.
there are questions that can be solved, but it has to be solved together with the software companies, with their poultry industry experts as well, and the poultry processors together.
I feel like this summit is that starting point. So, in your opinion, what has to happen to have all of this different types of data? So, you have automation data, you have sensor data, you have quality data, production data, and enterprise data, and they involve different departments, different groups, different personnel. In your opinion, what has to happen so everyone is having that same operational conversation? I feel like the summit is that attempt to put everyone in the same room so that they can talk to each other and network that way. What's your opinion on that? How do we make it part of the same conversation?
Yeah, I think this summit is absolutely great. And that's why I'm really looking forward to talking over there and meeting folks. And most interesting thing is when people from different backgrounds come in the same room, like operations, quality, and production, and so on. Like they need to sit down and understand and talk about what might be some of the top problems they want to solve. What are some of the top questions they want to answer that can improve their productivity, that can improve their efficiency, whatever that is. And each company will have a question that is slightly different but oriented in a similar direction. Now, once those questions are asked, it is then for us researchers and a technology company like our TraceR to see where we then develop our algorithms, we develop data-driven decision support systems that cater to that particular clientele while merging the data. But the first most important thing is get everybody in the room, which the summit is doing, which is a great
Mhm.
first step. And the second one is for all of them to sit down and ask the question, what do we want out of the data? How can we make better use of the data? How can I reduce losses, improve profit, improve efficiency, improve food safety? And that in turn in itself can spur a conversation which will lead to solutions. And
Mhm.
in the National Science Foundation terms, we call this use inspired research. It
I
is
love that.
them who, the processors who define what they want, how they want it, how they could potentially use it. So they have inspired that work, they have inspired the technology and inspired the technological solution. So it's a top down approach rather than a bottom up approach at the step one. Step two in the future could be both a top down and a bottom up approach, where the top down is, of course, them identifying the problems and then filtering it down and we providing a solution. But the bottom up approach could be like the digital twin situation, where the industry
Mhm.
has not thought about. And then we develop that, bring it together and merge it and say, okay, well, let's see how we can take it to impact our industry. And in that also is pull innovation and push innovation. Pull innovation is when you have external forces which are pulling, and then you have the push innovation where internal forces are pushing something
Mhm.
innovative out. So all the combination of all of this can, all this merger could happen and great discussions could happen at the summit, and I'm very excited to see what comes out of it and how we can make our poultry industry even better.
Yeah, me too. Do you think that combination is the biggest opportunity to improve interoperability, or do you think that the digital twin, as you mentioned before, is maybe that the strongest key component for interoperability?
I think a digital twin is so
Mhm.
there are multiple things in Industry 4.0, and digital twin happens to be part of it. I mean, there could be interconnectedness of data. I mean, we can start simple. Answering your previous question, here is one of the bigger scary factors. Oh, Industry 4.0, I don't know, it's just too much. It is not for me. I don't really think about it. It's the same thing what we said about cars, telephones, and when they were forced, well, couriers that were carrying messages on horses across the country, and they were running horses and stuff like that.
Yeah.
Then we came telegrams, and then we had the cars, and then we had now self-driving cars, and so these innovations happen. It takes time, but also most importantly is that we need to take a small step, stepwise approach rather than putting everything on a plate and say, go ahead and gulp it down in one single sitting. That's not going to happen.
Yeah.
That is happening to our industry right now as we speak, is a very young, enthusiastic leadership team across the board. Very, very excited. I mean, where I work with a lot of poultry companies, and they have young, enthusiastic teams who are coming on board and are establishing, and they're looking forward to new technologies. So I think the timing is just perfect at this moment.
Yeah. It's refreshing to see, and it's really exciting because I know the younger generations kind of get flack for, oh, they don't want to work. But I've talked to so many individuals from Gen Z, and they just have a huge sense of purpose. So they want to know the why and connect that to their sense of purpose. And just some of the ideas that they have are so inspiring. Makes me feel dumb at times. Like, I'm just like, where did you come up with that idea? But it's really refreshing to see. What do processors need to have in place before AI or advanced analytics can really deliver meaningful value for them?
They, if they have, they have data streams that can be, you know, we'll have to merge the data streams and make sure that so so the data that comes in, it comes in all different forms, and what we
Mhm.
want is to make sure that the format of the data is uniform, or there is a way that we can standardize the data coming in. And if we have that, it will make life much more easier for us to use the data.
Maybe a better way to ask that question then is, if a processor wants to start moving towards Industry 4.0 in a practical way, where should they begin then? Like, do they need to have a clear understanding of the data? Do they need to know what data is important to them? Like, where should they begin their journey?
I think the first thing that they need to know is, where is the data coming from? What
Okay.
format the data is coming from? And most importantly, what is important to them? What are the questions they want to be answered? If we are clear about the questions to be answered, it would be fairly easy and feasible to actually design a solution around it. Say, for
Gotcha.
example, a company has already having dashboards and data dashboards and gobs of data coming in. A company like ours can come in and design decision support systems where we can understand the data better and create certain decision support systems for our processors as well on the existing dashboards. So there are processors at different level of maturity, and
Okay.
we can design solutions according to those particular processors. But to begin with, like I said, they need to know what they want.
Gotcha. Okay. So with the summit coming up, what do you hope attendees take from your session and bring back to their own operation? So why don't you dig into a little bit what you're presenting at the summit and what you're hoping the individuals who attend your session take away from it?
I want them to know that the poultry industry is already close to achieving Industry 4.0. It's not as scary and a distant dream, and it's not in distant future that we are going to achieve Industry 4.0. We are almost there. I want them to know that there is help, and there are people, there are companies who have expertise and experience in digesting the data and providing them easier softwares that can provide deeper data insights for data-driven decision making. The most important thing I want them to know is there is enough work being done as we speak on ensuring data privacy and ensuring cybersecurity.
Awesome. Well, Amit, this has been such a great conversation and very educational for me because I'm sort of new in the food manufacturing industry. So I'm really excited that I had a chance to talk to you. Is there anything else that you want to conclude with before I let you go?
The poultry industry is absolutely a leader when it comes to technology. We have technologies that are already collecting data, that are already sending data to individual dashboards. We are just one step away from achieving Industry 4.0. And if we could achieve that in a small baby step manner, we will be able to improve our productivity, because in the future, it is data that is going to dictate what we do, how we do, and how we improve profitability. It is also imperative for all of us to merge poultry science, poultry quality, meat quality, operations with understanding data. And we need to train our people so that we can maintain our global leadership.
Excellent. Well, thank you so much for helping make Industry 4.0 feel practical and connected to the real operational challenges processes are trying to solve every day. So that wraps up this episode of the Popcorn Innovation Series, brought to you by Cat Squared and co-branded with Mavens of Manufacturing. The bigger story here is not just technology, it is how food manufacturers, processors, producers, partners, and operational leaders are working together to connect the dots across the full farm to fork life cycle. Because when data stays disconnected, decisions stay disconnected. And when decisions remain disconnected, operations pay the price in planning, yield, responsiveness, traceability, labor, margin, and trust. So this year's summit is designed to bring these conversations into the same room, enabling the industry to move from operational complexity to operational clarity. If you want to learn more about the summit, please visit the QR code here. Just scan it and that will bring you to Cat Squared's agenda and other information about the speakers who will be at the summit, the networking events that are happening, and I cannot wait for it. And I hope to see you all there and connect with you and learn more about the food processing manufacturing industry. Thank you guys for joining and take care. Bye.